Okay, this next bit is probably one of the most complicated bits that we're going to do in this particular topic, and this is looking at the idea of ions. Okay, so we'd already talked about the shells with the electrons in, and we're going to stick with that idea now. The important key point here is that elements like to be what we call stable. So what they like to have is a full outside shell. So it means what they want to try and do is get rid of those valence electrons that we talked about. So for lithium, where we've got one in that outside shell, or anything in group 1, sodium, they try to get rid of that extra electron because that leaves them with a nice full inside shell then. Now when they do that, they become what we call an ion. Okay, and that's what we're going to have a look at now. So we'll start with something nice and easy. So we'll go back to lithium because it's a nice easy one. Okay, so here's lithium. Okay, and we know it. Sorry, my light's in the way here, isn't it? We know that lithium has got 3 electrons. Okay, so on our first shell we've got 2 electrons, and on the outside shell for this one we've got 1 electron. Okay, now we do have to think a little bit here about what is going on inside our nucleus again, because the really important thing here is, as well as having 3 electrons, we've also got 3 protons, okay, in the nucleus. Now you also have to remember what charges we had on those things. So remembering that electrons each have a charge of 1 negative, and our protons each have a charge of 1 positive. Okay. So in total, if we've got 3 electrons, we're going to have a charge of 3 negative, and we're going to have a charge of 3 positive for 3 protons. So total we've got 3 negative and 3 positive. Now if we lose this outside electron, which lithium wants to do, so off it goes, we've now only got 2 protons left. Oh sorry, we've got 3 protons, we've lost an electron, we've got 2 electrons now. So this changes the amount of negative charge we've got. Now we haven't got -3, we've got -2. Now we learnt right at the beginning that usually our atoms are all neutral. But now we've lost one of our charges here, we're going to find that our atom is no longer neutral. So if we think the way we would do this with basic math, if we look at the 2 charges, we've got -2 plus 3. Now if I asked you to do that in maths, hopefully you would tell me that the answer is +1, and that's exactly the answer that we're looking for when we're looking for an ion. So what we would say is that now this is an ion, now it's lost that extra electron. Instead of just being lithium, it is lithium +1. It now has a positive charge on its ion. Okay. Now a good I guess way to remember this, as well as just being able to work it out, is that anything in group 1 has a 1 positive charge on it. Okay. So if we looked at sodium, which has got 11 electrons on, we would have 2 in this shell, 8 in this shell, and we'd have that extra 1 on the 3rd shell. It would still try and lose 1. Okay, so this time we would have 11 protons and 10 electrons, but if we do -10 plus 11, we still get +1, so it would be Na +1 in group 1, so it's a +1 charge. Okay. The other thing to remember is that all metals that we look at will be positive ions. Okay, so that's what happens when we are looking at metals. Okay, now if we look at non-metals, we have something a little bit different happening. So what we're going to do now is we're going to flick over to group 7 of our periodic table, and we're going to have a look at fluorine. Okay, now fluorine is a non-metal. Okay, so if we have a look at fluorine, our electron number is 9 for fluorine. So 2 electrons on the inside shell, and then we need to make that up to a total of 9. So we need 1, 2, 3, 4, 5, 6, 7. Now you can see that the inside shell's full. We've got 2 electrons there, and to make a full outside shell we would need 8, but we've got 1, 2, 3, 4, 5, 6, 7. So this time we want to gain an electron to fill up that outside shell. It's much easier to gain an electron than it is to try and get rid of 7 of them. Okay, so again we've got 9 protons, so we've got 9 positive charges. Oh my gosh, I can't spell tonight, can I? Protons. We'll try that again. And we've got 9 electrons. Okay, so 9 negative charges. Now what we're going to do is we're going to grab an electron from somewhere else and add it in. So now, instead of having 9 electrons, we've got 10. So now we've got 10 negative charges. So again, if we do the same thing that we did before with our math, we're going to have 9 plus negative 10. Now hopefully, like you would tell your maths teacher, you're going to tell me that 9 take away 10 gives you negative 1. Okay, so now what we have is non-metals leading to negative ions. Okay. And in group 7 what we get is that they're all negative 1. So our fluorine ion would be negative 1, fluorine negative 1. So anything on your periodic tables, that's fluorine, chlorine, bromine. Okay, we don't go down any further than that. Negative 1. Now if you're in group 6, so if you come in 1, negative 2. Okay. Now the very last thing to remember with non-metals, and you will have seen this when we've done other compounds, is when they become an ion, they also change their names. So with this one, we wouldn't call it a fluorine ion, we would call it fluoride. Okay, oops, so my spelling is atrocious. Oh, okay, so this becomes a fluoride ion. Okay. And we'll look at that a little bit later on with some other compounds. Okay, so basically if you can remember what group something is in, that will be a huge help. If you can remember if it's a metal or a non-metal, that will be a huge help. Otherwise, think about the electrons, draw the diagram if you have to, okay, and then think about what ion it's going to become. But you should be able to think about it just from where they are in the periodic table, just before what you know about how many valence electrons they've got, If it's a metal, it's going to be a positive ion, non-metal, a negative ion.